Hi, and welcome to another Vehicle Framework tutorial. This video will cover the creation of a new upgrade module, Crabsquid Protection. Crabsquids sometimes create EMPs that temporarily disable nearby vehicles. If the vehicle has a Crabsquid Protection module installed, it will activate at that time, draining power but preventing the vehicle from being disabled. In order to show you how I will implement the Crabsquid Protection effect, I'm going to use two special tools, dnSpy and a Runtime Editor. dnSpy allows me to inspect a decompiled version of Subnautica's source. A Runtime Editor allows me to inspect Subnautica's game objects in-game. They are invaluable tools when writing patches. dnSpy can be downloaded from its GitHub repository, linked in the description. The Runtime Editor I use can be downloaded as a BepInEx plugin from Nexus Mods, also linked in the description. First, we will set up a simple BepInEx mod. Then we will register a simple upgrade module with Vehicle Framework. Then we will use dnSpy and the Runtime Editor to implement the Crabsquid Protection effect. I'm going to start making the BepInEx mod now. I'll start by creating a new Visual Studio project. It should be a class library for the .NET Framework. Make sure to use .NET Framework 4.7.2. I'll name this project Crabsquid Protection Module. I'm going to start by renaming Class 1 to Main Patcher for the sake of convention. The first thing I'm going to do is add references. To do so, I right-click on the References tab and choose Add Reference. I'm going to need these references: Harmony, Assembly C#, BepInEx, Nautilus, Unity Engine and Unity Engine Core Module, and Vehicle Framework. Assembly C# is the only reference that an upgrade module might not need. Assembly C# becomes necessary if we want to write a patch on the game's files. We will be writing a patch in this video, so I'm just going to hit OK. I know already I'm going to be using more libraries, so I'm going to add those using statements now. Now, to start implementing my mod, I'll make Main Patcher a base Unity plugin. By making this class a base Unity plugin, we imbue it with BepInEx capabilities. To complete this process, I need to decorate my class with certain attributes, so I'll do that now. The BepIn plugin attribute describes our mod. The first parameter is the GUID. This is a unique string corresponding to this mod. I format all mine like this. The class ID is the name of the plugin, and the version is a number that increases when the project updates. We also require a start method that will interpret our patches. Although Visual Studio says there are no references to this method, base Unity plugin inherits from mono behavior, so Unity Engine will call start when this component is first enabled. I can instantiate a new harmony like this, and execute our patches like this. Notice this string is the mod GUID. Because they are the same, I will represent that data using a const string. Okay, now the BepInEx plugin is prepared, but it won't do anything yet. So we'll begin setting up the Crabsquid upgrade module. I'm going to start by adding a new method called add Crabsquid protection module. And I'm going to invoke it and start. The goal of this new method is to call the vehicle framework method to set up a new passive module. Add passive module is the right choice for Crabsquid protection because the upgrade should be active all the time. But there are other kinds of upgrades. We could call add toggleable module, add selectable module, or add selectable chargeable module. Unlike passive modules, toggleable modules can be enabled and disabled by the player. On the other hand, a selectable module can be clicked by the player to activate it once. Similarly, click and hold followed by release will activate a selectable chargeable module. Add passive module takes 7 parameters. I'll set them up now. The class ID is the in-system name of the upgrade. The display name is the name that the player will see. The description is a brief sentence or two about the module. The recipe is a list of pairs. The left item of a pair is a type of ingredient. The right item of a pair is the amount of that ingredient to use. I happen to already have a recipe set aside for this project, so I'll add it now. I chose a power cell, advanced wiring kit, and computer chip to hint at how the upgrade deals with the EMP. I also chose a single titanium to represent the body of the upgrade module. The onAdded action is a method that Vehicle Framework will invoke when this upgrade is added to a vehicle. We will actually not use this at all, but it's important for other upgrades. For example, if a module has stacking behavior, these parameters would be useful. The onAdded action is also an excellent place to make modifications to the mod vehicle itself, here called MV. Add passive module requires a sprite as well, and I've left a stub. You can see it underlined in red here. With Nautilus, this method is easy to implement. I'll go ahead and do it now. Images in Unity are often required to take the form of an atlas.sprite. Nautilus provides the method loadSprite from file that makes it easy to get an atlas.sprite from a PNG in one line. This depends on me having a file in my mod directory called Crabsquid module icon.png. That file should really be a PNG, and its dimensions should be 256 by 256. The final parameter to add passive module is the tab name. Tab name specifies with what other modules this upgrade should be grouped. This affects its placement in the Fabricator menu. In this case, MVCM is a name I've used for other modules, and it stands for Mod Vehicle Common Modules. That wraps up the BepInEx, Nautilus, and Vehicle Framework parts of this tutorial. Now we just need to implement the Crabsquid effect. All I know at this point is that Crabsquids do an EMP action, and that I want to subvert that somehow. I need dnSpy to move forward. In dnSpy, I will load the game's main assembly. It's called assembly C#, and you should recognize that from before. dnSpy lists different classes in Subnautica here. There are classes like player, and vehicle, and creature. It would be convenient if the creature I know as Crabsquid has a class of the same name. Unfortunately, it is so. But naming is not always so easy. For example, the class that holds the player's HP is called Live Mixin. I don't know why. If you know why, please let me know in the comments. In the Crabsquid class, there is some interesting information, but none of it seems to have to do with an EMP. However, I can tell that the Crabsquid truly is a creature. Unfortunately, the architecture of creatures in Subnautica makes this class unhelpful. To understand why, know that every creature has a set of behaviors. Depending on the state of the creature, it may select any of those behaviors to perform at any time. For example, proximity to player causes peepers to be more likely to flee. I like this architecture of behaviors, but I cannot see what creatures have what behaviors in dnSpy. This is because they are included on every creature's prefab. So to view a creature's behaviors, I have to use another tool called a runtime editor. This runtime editor can be shown by pressing F7, but other runtime editors may use a different key. However, I'm interested in Crabsquids, and there are none around. I'm going to spawn one in, but I'm scared, so I'm going to freeze the game by using the console command speed 0. Now I can carelessly spawn a Crabsquid. I type spawn Crabsquid, and then I search for it in the object browser. There's only one match, so I click it. And I can scan its top level components here. After looking through the components, I see some that look like creature behaviors. Swim random, stay at leash position, move on ground, descend to ground, attack last target, and EMP attack. That looks like something I care about. Let's check it out in dnSpy. EMP attack is only 135 lines, so I can scan it to get an idea of what it does. I have prior experience with creature behaviors, and the structure of this class is very telling. All behaviors have certain common methods, and those with perform in the name are usually the interesting ones. In other words, the perform methods tend to take meaningful action on the state of the game. So I'm going to read the perform method to understand what it does. The parameters to perform are not interesting to me, except I should remember that the creature here is a Crabsquid. It looks like this method does nothing at all unless a certain condition is passed. It looks to me like this is when the Crabsquid does its EMP attack. There are some operations on time. We read a few things. We normalize a vector. We calculate a distance. There's another condition here. We set some booleans. We set a boolean in an animator. This could be interesting. We play a sound. We play something else. Oh, look here. We cast EMP blast. That seems interesting. Let's investigate that more. To do so, I'm going to use the search tool, and I'm going to type the exact word, cast EMP blast. I got a match, so I'll double click it, and it's right there. This is a very small method, so I'll just read it. We work on some booleans. We get some time. We perform addition. We work on an animator. That could be interesting. And here we spawn a prefab that has an EMP blast. That seems like the most interesting thing in this method, so I'm going to click on EMP blast to go to that class. EMP Blast is only 168 lines, so I can scan it to get an idea of what it does. OnTouch seems to be the important method. OnTouch is a Unity engine signal that happens when something enters a collider. In this case, I'm interpreting that the EMP Blast has a collider, and those vehicles inside it get touched and affected by that. I can quickly see that in several places it calls the method disable electronics for time. Bingo. And in several places it's paired with the application of an effects overlay. This is our guy. Let's check him out. Fortunately, disable electronics for time is quite a simple method. Every energy interface has a list of energy mix-ins called sources. Energy mix-ins are associated with power supplying components like batteries. It looks to me like this method temporarily disables every energy mix-in that belongs to an energy interface. Now that I understand how the Crabsquid takes effect on my vehicle, I have a plan to implement my upgrade. My plan is to patch the energy interface class by adding a prefix to disable electronics for time. If my vehicle has the Crabsquid protection upgrade installed, then the prefix will skip disable electronics for time. That means disable electronics for time will do nothing. My electronics will stay online. But I also want to drain some power to use this ability. No free lunch and everything. So I won't forget about that. I'm going to start by creating a new file for my patch, and I'll do that now. Here I've implemented a bare bones energy interface patch over the target method. I know my plan is to sometimes return false, so I'll set up a conditional. When I return false, disable electronics for time will be skipped. The conditions I want to check are these. Number 1, the vehicle exists. Number 2, the player is inside the vehicle. And number 3, the vehicle has at least one Crabsquid protection module installed. So I'm going to write those now. The protection will not work if the player is not in the vehicle. This is simply to save energy. If the player is not inside, the vehicle will tank the EMP to preserve battery power. If the Crabsquid module takes effect, it should consume energy. I want the protection to be long-lasting, so the battery is never drained too rapidly. Keeping that in mind, I would like to start a coroutine to control draining power. I had to add a new reference to assembly C# first pass for access to the UWE. I almost always use uwe.coroutinehost to start coroutines. It handles them well across changes to Subnautica's game state. Right now this coroutine does nothing, but I'm going to use a simply timed mutex strategy to implement this coroutine. The effect this has is that the protection module can only drain power once every 5 seconds. Okay, this concludes the software part. Let's build it and test it out. To test out the module, Let's start by spawning a cricket and giving ourselves a module. I'll start by seeing what the EMP blast does normally. Okay, when the EMP is active, I cannot use my controls at all. My mouse and keyboard do nothing, and my lights are turned off. Let's install the module and see what happens. Okay, very cool. We can see that I never lost control, and I suddenly lost a chunk of battery power. Now that I know the upgrade works, I should just make sure I can really craft it. I can find the upgrade module here in the modification station, and I can craft it without an issue. Okay, that concludes this tutorial. Please consider liking and subscribing. If you have any remaining questions, please leave them in the comments below. In the future, I may create videos about the other types of upgrade modules, but they are quite similar to passive modules. If you have ideas for new upgrade modules, or new videos for me to create, please leave them in the comments. I hope you enjoyed this tutorial and sneak peek into Subnautica's source. Have fun and happy modding.